So when we're looking at our rules of exponents, we're looking at ways that we can simplify and that we can write this kind of one term. Now, one thing that we need to make sure that we're all on the same page with is that what operation is between the 2 and the m? Is it addition, subtraction, multiplication? What is between the 2 and the m? Multiplication. Yep. So we could also, I mean, we don't write the multiplication sign, but we could write this like this. Right? So this is what allows us to simplify. If we were to write it in a little bit of a different order, then we know 2 times 2 is 4. And here's kind of where the problem comes in, or the review comes in from last year, is how would we simplify this? What do we do with the exponents? We know that our base is going to stay the same.
You do times them or add them together. I know that.
We add them together.
So yeah, I had something.
Yep, good. So the rule that we're looking at when we have, I mean, technically how you would see it written in a textbook is a to the m times a to the n, and this just means that we have to have the same base, is the same thing as adding those two together. You don't have to write down this rule, but just make sure you have that example down. But that would be our first rule with exponents, that when we are multiplying two numbers together and they have the same base, we can just add those exponents and we could get our answer. So that's what we would look at in number 1, in those types of problems when we multiply.
It's not like that one Reese's Puff version.
I'm taking that as a compliment. So that covers.
Are they like spelling Reese's Puff?
Let's see. That covers a lot of those. What other types of problems do we see? Now, if we have a negative, if we have like m to the 5th times m to the negative 2, what would we do in this situation if we have a negative involved?
What? Still add it.
We can still add them. Yep. 5 plus negative 2
3
will just give me positive 3. Now, what about this? One more situation with when we're multiplying. If we had m to the negative 5 just times m, how would we simplify that? What would that be?
What?
M to the negative 5th, here, just go up, times m. How would we simplify that? Just m is really to the first power, right? We just don't write it. And then how many, if we go negative 5
Where'd
plus
you get
1.
5?
I'm just looking at other examples. That's not one of those on the sheet.
Okay, where'd you get 5?
Yep. M to the negative 5th times m, just m, or m to the first power. Negative 5 plus 1 would give me negative 4. Now, what you'll notice at the top of that worksheet, simplify, your answer should contain only positive exponents. So just like we don't like square roots on the bottom, we do not like negative exponents. Okay? Does anyone remember how we can rewrite this so it doesn't have a negative exponent? Any memories from algebra?
No. Only bad ones.
All we need to do to write and get rid of this negative exponent is put it over 1. That's it. So if a negative exponent, we can put the letter with the negative exponent on the bottom, put the exponent on the bottom, and put 1 on the top. So that covers all those examples that you will see with multiplying. Now the other type, there are 2 other types of problems that we will see. Oh, yep, 2 other types. That's where we're going next. If we look at one, let's look at number 12. If we look at like number 12. our rule when we have something in parentheses and it is to an exponent, our rule is that we multiply that exponent, or we give that exponent to both numbers and or letters in the parentheses, and we are multiplying. So 2 is technically to the what power? We just don't write it. 2 is just to the 1 power. So 1 times -4 would just give me 2 to the -4th. X is squared, so we go 2 times -4 would give me -8. Now, like we said, we don't like negative exponents. So how would we rewrite this? Yep, we would put all of it under 1. So we'd have 1 over 2 to the 4th, x to the 8th. Yeah. How do I get what? With the 2?
Yes.
So when we have our, this is what we started with in number 12. And when we have something in parentheses and it is to a power, they call it a power to a power, we have to distribute this -4 to both terms or both values in the parentheses. So technically 2 is to the first power, we just don't write the little 1. So 1 times -4 gives us 2 to the -4. Correct? And that covers the ideas on the rest of it. Now the last thing that we need to look at, let's look at a really complicated one, like number 29. This is number 29 on the back side, almost the last one. Yeah.
I have a question. Can I come to you?
This is the last example I'm going to look at, and then we can. So let's just look at one thing with fractions. If I have what does p squared actually mean? Like, how would I read? How else could I write p squared? Right. And p cubed would be like that. Now, if we had like something like
The whole circle and all lines.
kind of like what we had yesterday, if we have like 8 times 2 over 8, just like we could cancel out these 8s, and this would just equal 2, we can cancel out the p, and we'll be left with 1 over p. So in this example that we have over here, even though it's a lot more complicated, we have a lot more letters and numbers, we can just look at the individual letters or numbers and cancel out stuff when possible. So if we look at our numbers first, 4 over 3, can we simplify that at all? Can we simplify 4/3 at all? Nope, we can't. 4 over 3, simplest one. If we have m to the 4th over m squared, so we have 2 m's on bottom, 4 m's on top, so that leaves us with, we cancel them out, that leaves us with 2 m's on top. With our n's, we have 3 n's on top, so we have n times n times n on top. 2 n's on the bottom, we can cancel 2 out, so we are left with just an n on top. Now the last one with our p's, we have 1, 2, 3 on top, 4 on bottom. That means we are left with 1 on the bottom. So what type of rule, if we were writing a rule for what to do with when we are dividing or when we have variables that are in fraction form, or have fractions involved, what type of rule could we write for those exponents? What are we really doing with those exponents? Adding, subtracting, multiplying, dividing? Yep, we have n cubed over n squared. We said that is the same thing as n. Right? That we could cancel these out. What are we really doing with these exponents? Adding, subtracting, multiplying, dividing? We're subtracting. Yep. So a rule that we would write would be if we have a to the n over a to the n, it is the same thing as a to the m minus n. Would be the technical rule that we would write for that. If you want to think about it like we did here, that I have, that I have 5 my m's, I have 4 m's on top, 2 on bottom, so I can cancel 2 out, and that leaves me with 2 on top, then that's fine. If you don't want to think about it like subtraction, then that's okay. But really what we're doing is subtracting.
What about the P one? Because it's 3 minus 4.
The bottom from the top. Yep. So we have 4 minus 3 would just leave us with P on the bottom.
What about 2 minus 3?
Let's see. 2 minus 3. Technically that would give us negative, it'd be n minus 1 on the bottom, right? So to bring this, we don't like negative exponents, so to bring this n to the negative 1 up top, we can just make it an n. Which would give us negative 2 on the bottom, so then we can just bring n squared to the top. Yep, yep. Good job. So that is all the different types of problems that you will see on that worksheet that you have. Just like yesterday, well I guess not exactly like yesterday, you're going to choose to do either odds or evens, but we'll do front and back this time because these ones go a little bit quicker. So you can choose either odds or evens. I would like to work on this until big hands on the 11, so about 10 minutes, and then I want to turn everyone's attention to exam review.
I can't see 17 or 18.
Skip it.